Hello and welcome to this video. In this video, we're going to perform the kinematics experiment and going to find the acceleration from the position versus time graph and the velocity versus time graph using this air track. So, in this air track, we have the cart which is 500 gram and we have a motion detector that detect the motion of this cart if it is moving. So, if you say this, on that we can have we can make it an equilibrium position, so it can stay over there. So, how can we find the acceleration from this situation is like this. So, you are having the formula A equals to g sine theta. So, if we know the sine theta, so we can find the acceleration because g we know, which is 9.81. So, this we are going to make a situation like this. So, for example, this is our cart and we make it at an incline at an angle theta. So, this angle and this angle is theta. So, this height is h1 and this height is h2, and the difference between h1 minus h2 and this distance from h1 and h2 here is your d. So, now we have this triangle. So, we are going to draw it over here. So, this is d, this angle theta, and this is h1 minus h2. So, what is sine theta? So, sine theta is nothing but the opposite divided by the hypotenuse. So, opposite in this case is h1 minus h2 and the hypotenuse is d, we already know. So, take it the mod value so that it will give you always a positive number. So, your sine theta is this. When we are going to substitute theoretical value, so g, which is nothing but h1 minus h2 mod divided by g. So, this will give you the theoretical value of the acceleration. So, we can find the experimental value, which is A experimental, from the motion detector, and for that we are going to use these two plots, which is position versus time and velocity versus time. Okay. So, here we have the experimental setup. So, what we are going to check that our sensor is working. So, check that the sensor is working, the object is at rest, will giving me at rest. Okay. So, now what we are going to do to make an inclined situation like this, so what we are going to do, we are going to put it at some angle so that you can see it's moving. Okay. So, we make a situation like this is inclined. So, what we are going to measure the height, and we are going to start it over here, the 10 centimeter from here. So, we have from the surface, from the bottom to the surface, we have approximately 5.5 centimeters. So, 5.5 centimeter over here, and what is this? So, we have approximately 8 centimeters over here, or 7.9, yeah, 7.9 or 5.5. So, we are going to substitute. So, over h1 height, over h1 height is 5.5 centimeter, over h2 height is 8.0 centimeter. So, our sine theta will give us h1 minus h2 positive value divided by your d, and the distance between them we take it as one is at 10 and one is at say 80. So, we will get d, which is 70 centimeter. So, when we are going to substitute the value, so we will get A equals to g sine theta. So, this is your theoretical value. So, now we are going to substitute over here. So, here h1 is 5.5 centimeter. So, h2 is 8 centimeter. Your sine theta, you will calculate sine theta from h2 minus h1 or h1 minus h2 d, and then you will get the theoretical value. Now we are going to perform the experiment to get the value from the experiment. Okay, so you are going to take it, the motion over here, so make it there, because if you put it like this sensor will be will detect your motion. So it is, so start from here, start collecting it and then leave it. See this? So when you see this, so you are going to select it and make an auto, and then auto, make it auto, all auto scale, and then make it over there and auto. Okay. So now this is your position versus time graph, and this is your velocity versus time graph. So what we are going to do, how to find the slope. So this curve is look like a versus t squared plot. So it is like this. So we are going to fit it. Okay. No, we already drawn. So we are going to select at this region, and we are going to select this. Okay. So when you put it, so you will have 80 squared. Okay, try to fit it. So this will give us a coefficient a, b, c, and similarly for that we are going to get a slope as well, and this is a linear fit because it is a velocity time graph. So the slope is this. So if you see the equation, see the equations, so your position equations will be like this: x equals to x naught plus v naught t plus 1/2 at squared, and your, if you can write it like in terms of 1/2 at squared plus v naught of t plus x naught. So this is your a, this is your b, and this is your c when you see the, when you see this. So your a is 0.07825, your b is negative this, and your c is this. Okay. So if you wanted to find the acceleration, so your acceleration, so your acceleration 1/2 acceleration is equals to a. So a is 2 times the acceleration. So whatever you get the value of a, you multiply it with the 2, so you will get the experimental value. So 2 multiplied by a will give you this, and similarly in the case you will find error e minus t. So theoretical value, experimental value minus theoretical value divided by theoretical value multiplied by 100% will give you the percentage of error, and it should remain less than 5% if you are doing good. So this is acceptable error. So you will perform the experiment again and again, and then you get the average value. Similarly, this is the acceleration versus Vt. So now this is your plot, Vt plot. So this is your slope, which is the acceleration, you substitute it over here. So in this Vt plot, this is not multiplied by 2, just a is z. Similarly, whenever you have this, so your a experimental will become 2 multiplied by capital A, which is the coefficient here. So while using xt plot, you use this a, and while using the Vt plot, you use this a, which is the slope of the acceleration. So this is how you find the experimental value and the theoretical value of using the kinematics motion problem. So if you wanted to store and again another reading, so go to experiment and store latest run. Similarly, you will get to perform another reading. So you will start taking it and then leave it. Okay. So, similarly you will get the another reading again, and you substitute in this sheet to get the acceleration theoretically and experimentally. Thank you.